In this video, what we're going to do is we're going to get started by creating the AI. So the first thing we need to do is we need to separate the pawn skeletal mesh depending on whether it's a player or an enemy. We don't want to use the same skeletal mesh for both, so what we're going to do is we're going to set up some dynamic code to make so that the code will read off of whatever we decide it to be based off of what the map designer or the level designer puts into the map. So to get started, we need to do is we need to create our information classes that's going to hold this information for us. We could simply put it in, for the player, we could put in the player information class, and I guess for the enemies, we could possibly put it inside of our Puzz AI controller class and just fill it up full of code, and, endless code lines if we wanted to. But to make it a little bit more easier to read, to find things, we're going to separate things up a little here. So we're going to create these information classes. First one's a Puzz character information class and extends from object. And in there, we're just going to create the 4 variables that hold the information for the skeletal mesh. We have the anim set, which is the animations, the physics asset, which is for physics, the skeletal mesh for the visual, and then the anim tree to make the anim sets work and flow properly. Once we have that done, we go and create another class called Puzz player information, and that extends from Puzz character information, and inside of there we create our default properties for those 4 things. All these things point to something inside of our content pack. Now, this is the base class for Puzz player information, so if you wanted to have multiple different versions of player information, you probably would extend from this and then probably put this inside of one of them and not inside the base class, unless you wanted this to be just the default at some point. The next one is going to be our Puzz enemy information, and that extends from Puzz character information. And we don't want to put anything in here just yet, but there will be plenty of stuff that goes in here as the game moves along. For now, it's just going to remain empty. And then we extend from that to create our first mob, Puzz enemy information underscore melee mob, and that extends from Puzz enemy information. And there we set once again our stuff from our content pack. Now this really shows inheritance at work, because what we do is we have Puzz character information. From there we sprout 2 classes, the player and the enemy information. And from the enemy information we sprout numerous classes if we want to, numerous enemies, and we have Puzz enemy information melee mob. Also, melee mob is not because it's a melee mob. I mean, it will be, but it's not because we're sprouting from that to create other mobs of some sort. This monster is actually just called melee mob instead of coming up with some name. So if this was like a goblin, for instance, I probably would have called it Puzz enemy information goblin, but it's not a goblin. So, okay, now that we have that done, we go inside a Puzz pawn. Now what we need to do is we need to access these information classes. So in order to do that, inside a Puzz pawn, we start off by creating a variable of class Puzz character information, which is the total parent class of the whole thing, and we call it chart info. Inside of a function called possessBy, this function gets called when the controller possesses the pawn. This is already code that's established from the parent classes of Puzz pawn, so it's probably in pawn, most likely in pawn class. We do super.possessBy because we want to keep that code whatever existed before, and then we're going to set character information. In order to get what we want to pass into character information, we call on a function called getCharInfo, which is another thing we're creating. GetCharInfo is used to grab the information for this pawn. Set character information is used to actually set the information for the pawn. So we start off by going inside of our getCharInfo, which returns a type of class called Puzz character information. It doesn't pass in any parameters because none are needed. And inside we just do a local Puzz player controller Puzz PC, and then we set the Puzz PC by typecasting it to the pawn's controller. And as long as the Puzz PC is not equal to none, so as long as it was a Puzz player controller, then it will not be none, and then it will return Puzz PC.Puzz player info. Puzz player info is something we'll be creating in a moment inside Puzz player controller. If it is not, then it's going to return char info, which really, in all honesty, is equal to none at this point. Later, when we get into adding the AI, we will be adding a Puzz AI controller in here and testing to see if that's not equal to none to set the AI information. Then once that, let's say for instance it is a player and it calls it, it will return this Puzz player info, and then it'll cast it into this set character information and use it as a parameter. So we go down to set character information, and the first thing we do is we check to make sure that it's not already set. So if chart info is already equal to what we're trying to set it to, there's no reason to change this stuff because it's already there. Now if it wasn't equal to it, then we need to change it. So uh, this is what that'll do. So if it's not equal to, which it won't be, we do mesh.animSets equals puzzChartInfo.default.puzzAnimSet. So we're grabbing um, the default value of the puzzAnimSet. You can do this default whenever it's a class you're using. Now, if you're using some sort of actual instance, you wouldn't need to do .default. You could just do like .puzzAnimSet. But because we're using a class, we can only access static information. So in order to do that, we need to access the default information. We also do mesh.setSkeletalMesh, setPhysicsAsset, and setAnimTreeTemplate. All these functions are things that exist inside of the skeletal mesh component, since mesh is a skeletal mesh component that was originally created inside the pawn class. And so all of these, so that's pretty much what these things do. All they do is they just set this to the actual skeletal mesh component we created in our default properties. Then what we do is we set chart info equal to puzzChartInfo, so that way this won't get called on again if we for some reason go to set character information. The next thing we do is we check to see if it was a puzz player controller, and if it was a puzz player controller, then we're going to go ahead and create the player information, which we'll show you in a second. The player information instance is actually going to hold, it's going to be kind of like a data source in a way. It's going to hold all this information for you that you can access as the game moves on. You could use it to save your information, you could use it for numerous things. So we might, so later we might say to ourselves, well, if we wanted to add some sort of special abilities or like strength or constitution, things like that, if it was an RPG, you probably would put them inside of this and then save it, and then you could create your own save files based off of the players. Okay, now once that's done, we can move on to the Puzz Player controller. Inside of there, we create two variables. First, there's variable class Puzz Player Information, which is Puzz Player Info, is what we call it. And then there's a variable Puzz Player Information, which is Player Info. As you know, the difference is this one refers to the class, and the other one refers to an instance of the class. Now, here's our create player information, and all we're going to do is we're just going to create an instance. So we're going to set player info to equal to a new version of this Puzz player info. So it's basically like spawning something, but it's not creating it in the game. It's just creating it in the system, in the actual, I guess, memory of the game, not so much in the visuals of the game. Okay, now down at the bottom of default properties, we're going to set the Puzz player info equals class puzzlegame.puzz player information. So that's pretty much where it's going to get grabbed from and pulled in. So that's how come, and if you go back in PuzzPawn, when we go to our get chart info, when it pulls this Puzz player info, it's already been set in default properties to our player information. If you wanted to create something where you got to choose your own skeletal mesh at the beginning of the game or something like that, some sort of different pawn with different abilities, obviously you would be sprouting out different things off of the Puzz player information. Well, what you would have to do is inside the game is you would have to, somewhere along the way when the player decides what character he's going to be, you would have to change this default off. So you would basically set this Puzz player info somewhere probably inside of your game file. And then that would override what's in the default value. And then you can then, of course, go when the pawn does get called on, it'll transform it into that pawn, not the default pawn. Our next step is, now that we have it working, if you were to run the game right now, you would see the pawn running around and doing its animation. Our next step is we need to get the AI going. Now, the AI doesn't have any start points at this point. The original code was based off of all player starts, and you just set teams up, and they just spawned, and it was kind of like a random spawning event kind of thing. So it really wasn't created for this type of game. So we need to create our own kind of spawning system for our AI. So what we're going to do is we're going to create our own start point. To get started, we're going to create a class called Puzz Enemy Start Point, and it's going to extend from Navigation Point, and that's an abstract class. And we're going to have two variables, B in use and AI type. AI type, of course, is going to refer to whatever the mob name is, and B in use is going to just let us know if this enemy start point has been used. The reason is we're using B in use is because we want to know if we're using this start point already. And if it's been used, we don't want to respawn this creature continuously and things like that. If we want the creatures to respawn, then later we can set the being used to false or however we want to, so we can reopen that start point and then allow the pawns to continuously respawn throughout the map. In default properties, we're going to remove two sprites, just things that we don't need to look at anymore that don't really have anything to do with our game. And then we're going to have our skeletal mesh component, which is going to hold the look of of this creature in the map editor. So when this person puts down a start point, it won't be like a joystick like the player start is. It'll be an actual representation of this creature. So the person who's making the map, the level designing, will see the creatures in the map where he placed them. So it makes it a lot easier to know where you're placing what. So we're just going to have a begin object class skeletal mesh component. It's just going to be a placeholder and object components.add placeholder. We're just adding the object. We're not even setting the skeletal mesh at this point because we're going to set it later. And then we're going to do B edge should snap to true and B hidden to true. B hidden makes sure this does not show up in the game when the game starts, and B edge should snap means it should snap to the editor when they place it in the map. In the map, it should snap to the floor as opposed to like floating out in space or something like that. So after we create that, we're going to go to puz enemy start point underscore melee mob, and it's going to be a placeable class because we want to let the map editor or level designer, whatever, actually be able to place these start points in the map. And we're going to set a class group called enemy starting points. Now this is something new. Class group, what it allows you to do is when you go into Unreal Front End and you load up the map editor, and you go to your content area, under the actor section, there's numerous class groups you're going to see. For instance, the pickup factories are under pickups. Well, by creating this class group, we've basically created this now for if you wanted to find the enemy start points, they're going to be under enemy starting points. This didn't exist until we did it. That's pretty much what it does. Now, in default properties, we're going to set our placeholder. We were going to open it back up and then create a skeletal mesh for it that's just related to this. And we're going to set the AI type to melee mob. Now, it's important to have consistency here because what's going to happen is we're linking melee mob not only to its starting point, which we're calling underscore melee mob, but also to the puz information class underscore melee mob. And this is important because eventually we're going to also use the code and point to melee mob. And if you were to say, oh, well, I want to call it something else here, but I want to call it something else there, you're going to end up causing your code to be very confusing. So it's very important to stay consistent so that it's very easy to continuously code using your current code. If you start changing things up and switching names and doing all these different things, you may find yourself forgetting what you called it where at what time. So just stay consistent as you go along. Now that pretty much completes this video. Like I said, at this point you'd be able to jump into the game, run around with the creature or with the player, and then later we're going to be adding these start points and then making them work.